Saturday morning, most of you having first cup of coffee, so don't slow. Let's see how far we go. Let me give a little bit of history, how it all started. This is 101 field of physics. So it all began during the space race. Do you remember that? I wasn't even born. I don't remember much of it, but I read lots of books about it. So there was a heated competition between the Soviet Union and the United States at the time. And what scientists from NASA and from the Soviet Union realized was that the weather in space can be rather stormy. So the first discovery, major discovery of the space air was made by Explorer 1, the first NASA satellite. And the discovery was basically the radiation belts, the Van Allen radiation belts. There was a Geiger-Müller counter on board this first satellite, and it was knocked out when it crossed the radiation belt. So that basically gave people at NASA a hint that there is this donut-shaped region encircling the Earth that contains very high-energy electrons. And basically, the particle flux there was enormous, and the Geiger-Müller counter was not calibrated to basically withstand this high dose of radiation. Then a year later, Soviet scientists sent the first spacecraft orbiting the moon. They wanted to gather some measurements in the vicinity of the moon so that they can plan for their future missions to the moon. So there were a number of milestones along the way during this space race. So first was to send people to orbit the Earth, and the ground goal was to send people to the moon. But in order to send people to the moon, you need to know what the environment you will encounter on the way to the moon. So NASA scientists were running behind at that early stage, 1958, 1959. Soviets were one step ahead. So when they sent the first spacecraft to visit the moon, they discovered this the solar wind, which is basically charged particles, mostly protons and alpha particles, streaming away from the sun and basically filling the entire space from the sun to the outer boundaries of the solar system. So that basically gave a hint that there is some particle radiation that exists outside the protective shielding of the Earth's magnetosphere. And that was a very major discovery. And then we had a series of missions. At the end, we know that the Russians failed to send manned crew to the moon. Instead, NASA succeeded. There were lots of missions. And one of the last missions was Apollo 17. This was the last mission that aimed to send people to the moon. Why? Because they made some fundamental discovery in that year, 1972. Basically what happened, on August 4, there was a major storm. There was a major ejection of mass coming from the sun. And that produced a very powerful flare. So if people from the two astronauts, Schmidt and Kernan, who were supposed to go to the moon, if they traveled in August rather than December, they would have been killed on the spot. Because there was a very powerful flare, as I said, and the dose of radiation that they would have experienced was 1,000 rem, which is over 50 times larger than the allowable dose of radiation that a human being could experience in a lifetime, which is only merely 18 to 20 rems for a typical 70-year lifespan. Okay? And the same year, NASA launched the first space laboratory. It was a mini lab sent on a rocket, and during this mission they discovered these huge bubbles expanding away from the sun, and at that time they were called coronal transients because this is not something that goes steadily, but it's transient. It happens anywhere between a few times per day to a few times per week, and at that time they called them coronal transients, but later on they were named to coronal mass ejections because coronal mass ejection is a more characteristic name of these phenomena. I'll tell you more about these coronal mass ejections a little bit later. So the bottom line is that since I was born in 1972, no more astronauts were sent to the moon to conduct experiments, play golf, whatsoever. And now we had a renewed vision a couple of years ago from former President Bush to send people to the moon and Mars. But as of now, that's going to be a suicide mission. Simply because when you look at this number, during a major flare on the sun, you will have this amount of radiation. There is absolutely nothing to protect astronauts on the moon. The moon doesn't have magnetic field, doesn't have atmosphere like we do on Earth. So, and it's the same with Mars. So any other destination in the solar system would be, or most of the destinations in the solar system will be a suicide mission for NASA astronauts. But I'll go in more details about the conditions in interplanetary space.